Right, so in this video we have problem number 36, and we are asked to model with mathematics, and this is a um, word problem. So the number y of calories burnt after x hours of rock climbing is represented by the linear function y is equal to 650x. And I don't know if this is an actual function that's representative of this scenario, but this essentially means that if we have X hours of work. So, for example, if we had 1 hour of work, 1 hour of rock climbing, when I say work, I mean rock climbing, then we would have 650 burned calories burned. 2 hours, we would have 1300, and then so on and so forth. Find the domain of the function. Is the domain discrete or continuous? Explain. Let's do part A. So the domain of this function is the x values for this function. That's the hours. And the hours can be greater than or equal to 0. This is the domain. This is the domain of this function. Now, why can it be equal to 0? Well, we can also just not rock climb, so that would also be fine. But time can never be negative. That would break the laws of physics. So that's essentially this. And now let's look at the range. The range is dependent, so it's a dependent variable. We have dependent on the domain, and if x is greater than 0, greater than or equal to 0, y is actually going to be the same thing, greater than or equal to 0. Because if x is 0, then y is 0. If x is 1, y is 650. If x is 0 point something, it can also be a decimal. Then it can that means we would essentially have a fraction of an hour, which is completely valid. We can have, for example, 0.1 or 0.1 hours would be like for 0.1 or 10% of an hour would be what? Well, 10% of an hour is 6 minutes, right? 6 minutes. So yeah, we can have a value that's in between like the whole numbers. So that's actually answering the second part of the question. Is the domain discrete or continuous? It's actually continuous. This is a continuous domain, because this wouldn't be continuous if we had like chocolate bars as the domain or something like that. It's continuous because it's time. Time is continuous. We can have a second, we can have we can have a minute, we can have an hour, we can have all sorts of things. So time it's going to be a continuous domain. Okay, let's look at part B here. And we have to explain, right? So, time can be, in between the whole numbers, or in between. I'll just say in between the whole numbers. That's what it means. Okay, let's look at part B. Graph the function using its domain. So let's see here. So if we have the function here, using its domain, we're only really gonna worry about this right here. This is gonna be a line, and let me erase this here. You don't need this here. So when it says graph the function using its domain, we have to make sure that we don't exceed the domain in any way. So that's essentially what it says when it says using its domain. Well, x, which is essentially time, it can never be negative, so it can never go in this direction. And if x can never be negative, y is always greater than 0, so this is just going to be in this first quadrant here. And so if x is 0, that's 0, so that's going to be at this point. X is 1, it's going to be 650, so say 650 is somewhere here, I don't know. And then it would be here over here, but essentially this would be our function, and it would go up like this. And of course, this is a linear function because it's a line, and we have 650x. That's the rate of change. So if we were to draw like a triangle or something like that, right? This would be the length, the delta y. This would be the delta x, right? Essentially, but we don't have to worry about that. This is just essentially 650 by 1 is the rate of change, is the slope here. And so that's why it's a line. And of course, if we keep in mind the domain of this function, x needs to be greater than 0, so we have this right here. And just to connect back to reality, we obviously can't. We will have a restriction on x, right? Eventually, at one point, we can't go on forever because that's just not like possible. We would get tired. We would maybe the universe would end at one point because X cannot go on forever. But that's something that we don't have to necessarily worry about because we are talking about what's possible and what's not, and immediately X can never be negative. So I hope you found this video helpful.